Hello students, in this video we will prove that minus a into minus b is equal to ab for all a and b belongs to the set of real numbers. Let's start our proof. First of all, we take left hand side. Minus a into minus b. As we know that set of real numbers also satisfies the associative property with respect to multiplication. So we write as minus b. So we have three real numbers. Minus 1 is a real number, a is a real number, and minus b is a real number, as it is given that b belongs to real number. So we know that in the set of real numbers there is also a additive inverse minus b, which will also belongs to the set of real numbers. So minus b is also real numbers. So we have three real numbers, and now we can write by associative property minus 1 into a into minus b whole. By associative property we can write this. E f for all E f g belongs to the set of real number. So by associative property we can write that E f whole into g is equal to E into f g whole. So both sides are equal. So instead of this side, this we can also replace this. So here we have written both are equal, so we can write minus 1 into a into minus b whole. We also know that the set of real numbers satisfies the commutative property with respect to multiplication. So by commutative property we can write minus b into a. By commutative property, see the form of commutative property with respect to multiplication. By commutative property with respect to multiplication. See its form. If we have two real numbers d and f belongs to the set of real number, they are any real numbers. So if d and f are two real numbers, so we can write df is equal to fd. This is the form of commutative property with respect to multiplication. If we take any two real numbers, then they will be same. df is equal to fd. So by associative property we have written this minus 1 to minus ba. By closure property we know that if we have two real numbers, so their product will also be a real number. This is a closure property with respect to multiplication. So we suppose let BA is equal to T, and T will also be a real number by closure property. By closure property we can say this. closure property says that if we have any real numbers, so their product will also be a real number. To multiplication. So we can write minus 1 into minus t. Now we will also use associative property minus 1 into t. So by associative property we can write minus 1 into minus 1 here we multiply minus 1 into minus 1, we will get plus 1 into t. So by additive identity property we can write by multiplicative identity property, not additive. Multiplicative identity property. This property says that if we multiply multiplicative identity element in left side or right side of any real number, then we get this real number again. Its form is for all G belongs to this set of real number. G is an element and 1 is an multiplicative identity. It belongs to the set of real numbers. So 1 multiplied by G and is equal to G multiplied by 1, which will be equal to G again. So by multiplicative identity property we can write 1 into t is equal to t. Here we have supposed already supposed t is equal to ba. So we know that the set of real numbers also satisfies commutative property with respect to multiplication by commutative property. With respect to multiplication, also see its form. If we have two real numbers a, b belongs to the set of real numbers, so we can write ab is equal to ba. This is the form of commutative property. You can take any two real numbers and you can write that, you can also prove that AB is equal to BA. For example, 2 and 3 are two real numbers, so we know that 2 multiplied by 3, 3 multiplied by 2, both sides are equal. So left hand side is equal to AB. In this way we can say that left hand side is equal to the right hand side, because after solving we get right hand side value AB. Hence proved. Minus A into minus B is equal to AB. Thanks for watching and listening.